Let's do this problem. We're going to drop this ball, and this other one's going to bounce up, and it's going to bounce, it's going to hit this lump of clay. So let's get the speed of the ball right before it hits the ground. Hey, let's try this a different way. Let's use conservation of energy. mgh is what it has, and it gets 1/2 mv squared at the bottom. So we're going to get the m's cancel, and we're going to get 2gh as the speed. I'm not even going to do this with numbers. We want to know the time after the clay bob's release at which they hit. So here we go. The clay bob equation. X of the clay, -1/2 gt squared plus 0. But we start from a height of h. And for the ball, that's going to be -1/2 gt squared because the acceleration is still downwards, plus its speed at the bottom is square root of 2gh, but its initial height is 0. So they're going to meet at the same place. So it's going to be xc equals xb. When we set those equal, what we're going to end up getting is that h, and this is times t here, h, these two will cancel when we set them equal, equals square root of 2gh times t. And so the time that they're going to meet is actually at h over 2g. And that's the time at which they meet. And then the height, let's go ahead and get that height. So the height will be here. We can use, I will use formula C, so that's going to be x of the clay is -1/2 g, t squared is going to be h over 2g plus 0 plus h at the end. And so when we actually simplify this, it's going to hit it, these g's will cancel, they will hit each other at 3/4 of the original height at which we dropped the clay. Now I'm going to give you a hint for part D, a really serious hint. Assume they hit and stick. Find the speed right after they collide. Ooh, that'll be a really good question for you to practice on your own. Woo! Okay. And then I will do problem 2 in the next video.